students, in this video we are going to start with the next unit number 8, object oriented design patterns. In this unit we will study about the three lessons. Lesson number 1, implementing special object oriented techniques. That means now we are going to proceed on to the higher techniques that we can use in case of object oriented programming. Lesson number 2, we will discuss implementing the singleton pattern. In lesson number 3, we will implement factory classes using friendship. So start with the next lesson, lesson number 1, implementing special object oriented techniques. So there are a number of smaller topics that are useful in implementing in case of object oriented SAP ABAP. So the first topic is implement abstract classes. As you can see in this figure, we can also make a class as an abstract by using the keyword abstract, which is used to withhold a class from being instantiated. That means once you have made a class as an abstract, the class cannot be instantiated. That means you cannot create the object of the class. And the syntax that we can use in this case is class, then class name, then definition, then keyword abstract. Now come to the next topic. You can see we can also make the method as an abstract. So method of an abstract can be of type abstract. That means their implementation is not defined. So once you have defined the method as an abstract, you cannot define the implementation part of the method. But it is necessary to include that method, abstract method, in the abstract class. Now come to the next topic, final classes and method. Generally the final addition or final keyword in a class definition prevent it from being inherited. Suppose we have two classes, base class and derived class. If you make the base class as a final class, you cannot inherit into the derived class. So once you make the final addition in a class definition, it prevents it from being inherited. And the syntax is class, then class name, then definition, and then final. Now come to the next topics. All of the method of a final class are by default final in nature, which means they cannot be redefined. Suppose in a base class, if you have to define a method, and if you want to redefine into the derived class, that you can do with the help of method, method name, and then redefinition. Redefinition keyword is used for redefining the base class method into the derived class method. Suppose if you do not want to be redefine a particular method from base to derived, make it as a final, and the syntax is methods, method name, and then final. Come to the next topic, read access to a table with object references. Generally object references that are similar in nature are stored in the internal tables. Generally we use the internal tables to store the particular informations. So in this case, you can see in this figure, for defining the particular internal table, firstly we need to define the structure of a table, and we can define the structure of a table by defining the structure. And how we can define the structure? With the help of begin of and end of keywords. So firstly we are going to define the structure like this one, begin of, then structure name, then we are defining the component. The first component is here make of type string, second is model type string, and third one is a reference. This is a reference variable which is referring to a class LCL vehicle. So you can see in this table we have three components. The first component is make of type string, second is model of type string, and third one is the reference, which will store the objects or references of the another class. So here the class name is LCL vehicle, then end of structure name. Now for defining the intent table, how we can define types, then table name gty underscore t vehicle, then type table of structure name. So this is our structure name. Now we are going to define the reference variables. So defining the reference variable of the class gty underscore s underscore vehicle, as well as gty underscore t underscore vehicle. Sorry, in this case we are going to just define the variables. Now how you can read the table part, these references part, with the help of reference component. So there are two components, make and model, by which we can retrieve the information of the reference variables, and that column are called key information. These references can be easily retrieved by using the key references. So read table gt underscore vehicle into gs underscore vehicle with key is make, or you can take as a model. So by this way you can access the reference variable with the help of key informations. Come to the next topic, read access using public attributes. When information is stored in the internal table with the key values, the key attributes are specified as a public with a read-only addition to avoid the redundancy. So these public attributes can be directly accessed when the internal table are accessed. So when you are making the component make and model as a read-only, that component cannot be added into the further classes or outside of the classes. So if the classes which are outside of this class can only be read that particular value of these data members. So this is the concept of the read only. The keyword, the table line that is used when the line type of an internal table is of elementary data type. Now come to the next topic, navigation method and chaining of the method call. As you can see in this figure, we have a class LCL underscore rental, and in this LCL underscore rental we have an internal table empty underscore vehicle which is storing the references of the another class, and the class name is LCL underscore vehicle. And we have also the two methods, add vehicle as well as get vehicle. So how we can use this navigation method, how we can access the method of these classes LCL vehicles which are stored in the as a reference into the internal table of the rental class. So first of all we need to define the reference variable of the both the classes, go underscore rental as well as go underscore vehicle of type LCL rental as well as LCL vehicle. So first of all, how we can define the reference variable with the help of data objects. So data go underscore rental type referred to LCL underscore rental, go vehicle type referred to LCL underscore vehicle. Now what we are doing is here we are using a variable to store the reference to the vehicle. So first of all what we are doing, we are calling the particular method go underscore rental with the help of go underscore rental get underscore vehicle and assigning it to the go underscore vehicle which is the reference variable of the another class. Now by this reference variable you can call the method of the LCL vehicle. So go vehicle then display attributes. Now come to the chaining part, that two lines we can replace with a single line. So you can do all this process into a single line like this one, go underscore rental then component access operator, then calling the method get underscore vehicle, then component access operator, and then method name display underscore attribute. So therefore it is now possible to call a method of an object written by the navigation method. Now come to the next topic, implicit setting of the instance constructor visibility. That means you can also make the classes as a public, private and protected. This example shown in this slide gives a syntactical representation of the visibility concept. The visibility of the instance constructor is implicitly defined by the public, private as well as protected using the keyword create. So if you want to make a class as a public, you can use the statement create public. Then all the user can instantiate the class. That means all the user can make the objects of this class. When you create like this one, create protected, so only the class itself or its subclasses can instantiate the class. Now create private, the class can only be instantiated by the itself. So this was all about the lesson number 1. of the unit number 8.